So you want to jump right on things and get the facts. Have an immediate interview with the people that are affected. We'll try to not use the term complaint because generally people don't want to complain or be labeled as complainers. We like to call them issues or concerns. A little more politically.
Dave, this is Rich.
Correct. Yeah, Rich.
For the residential sector, the concerns might come from the family or from the Indian Health Services with someone with asthma or allergies or some sort of a health effect. So that would be an important thing to document and work hand in hand with IHS and the maintenance people or whoever takes care of those buildings.
Right. So during that interview, you want to find out who is affected, what's going on, where is it happening, when does it happen. These can all be very valuable clues to get to the root of the issue. This is too slow a response. Don't be this guy. And it's good to get your face right in there on the issue. Show up, look around, let somebody know that physically you're on the job. We can look at buildings and try and diagnose them, but we can't look at the humans and diagnose those. That's not our skill. So you want to get the medical community involved. And there are forums, if people care to share what's going on, they can share that information. And also keep an occupant diary to help establish the time pattern of when things happen. Is it related somehow to some other event that can be controlled? And once you get all your go ahead, Rich.
When we look at indoor environmental problems, typically something has changed. They didn't have a problem last month, but now they do. So we try and figure out and diagnose what changed that could exacerbate a problem or trigger a problem. So we need to look at the building, but we also need to look at the occupants' activities or medications that they're taking. Maybe the kids changed schools, or they've taken a class in ceramics or something like that, or somebody's got a different hobby, or maybe the weather changed and now there's pollens or something like that. So or maybe the heating equipment has failed. So we try and figure out what changed that could trigger a problem.
Okay, and then you want to agree with people of where you're headed, especially in a school setting. There's got to be an end point because you can't just keep going on testing, throwing hundreds of thousands of dollars potentially at a problem, testing for everything under the sun. You want to get things so that they're basically okay. Comfort's within guidelines. Air is moving in the direction you want it to. It's not stuffy. And noise is down, airborne particles are reduced, so everything's dry, clean, comfortable, controlling the pollutants you're aware of, and well ventilated. And hopefully that will be a decent outcome for everybody because we're headed for reductions in health effects, absenteeism, distractions, meds, doctor's visits, odors, etc. Now on the inspection, it's going to be a whole lot easier if you work at it as a team with the people that are being impacted. And as I just mentioned, the 5 benchmarks, it's just common sense benchmarks. It's not rocket science. Is the place dry, clean, comfortable? Are the pollutants being controlled? Is it adequately ventilated? As Rich says, what's changed or is different that might provide a clue? Initially, without the instruments we're going to be talking about, you can just use your senses. Look around, see what's there. Maybe you find a time clock that, since the power went off, has not been corrected that be causing an issue, for example. Use your other senses. Use your nose. This is my typical carpet check, which I can get away with. Maybe more sensitive people couldn't get away with doing that, but I find it useful. But you can use your nose to find the source of some of these ills. And you can sense, without potentially the chemical smoke and pressure gauges that we're going to be showing you, sense the way air is moving. You want it going from clean to dirty and then outside. And so you wouldn't want air coming out of this door where the asbestos hazard lurks. And you can usually sense that with a piece of paper, a feather, even your finger up close to the crack in that door. You can evaluate cleanliness without instruments. Take a look around above the ceiling tiles. Never know what you're going to find. So get dirty, but be safe, looking on all 6 sides of the affected room, if it is an individual room, and use your personal protective gear. Keep yourself protected from the elements that are out there. And we'll move into when we do use measurements. Why use measurements? It can be useful to confirm or rule out causes of what's going on, to provide precise remediation instead of overkill, and to check and make sure that things were done properly when all is said and done.
Looking at the remediation, Dave, we want to make sure that we don't have those unintended consequences where we solve one problem and create another.
Right. And we only want to take measurements that we can reasonably interpret. You don't want to measure for stuff that once you get the answer back, you have no idea what that means. That's a waste of time and money. So only grab measurements of these reasonable parameters that you can own and actually do something with. It's true that what gets measured has a better chance of being managed, controlled, or fixed, but you've got to be able to interpret the results. Here's an example of a school district that spent literally $730 grand on a problem. It's still a mystery. And then they didn't release the results. I want to make the point that any measurements you take in a school or in a home, you want to share that the results right away with the people. Here this teachers union had to sue to find out measurement results in the school, and that's really not the way it ought to be done. When you do anything in an investigation, it ought to be an open book with everybody involved. Maintain that trust. So this is some of the gear we use, and it's getting pretty fancy, and maybe pushing towards $15,000 to go all the way with some of these instruments, maybe a little more, but you can do a whole lot with less too. And we're going to talk about a variety of things today. I'm going to start off with moisture. There's a lot of interest in moisture and mold out there. And as a basic rule of thumb, if you're living in a moist environment, chronic moisture issues, that's just bad. It's just unacceptable. What typically happens when you have moist environments like that chronically is you get mold growth. And mold needs moisture. These are the 4 things you need for mold to grow. You need your spores, which are everywhere, virtually. The food, and it's pretty easy to find, paper or wood products, which they really like. They like the same temperature we do, a nice Mediterranean climate, and they need lots of moisture to live. The one thing that we can control readily is that moisture. So that's the key to preventing mold growth. How do we find the moisture? We have these handy little meters. This is maybe what, Rich, $300 or $400, maybe a little less.
$3.25, something like that.
Yeah, you can see that the needle is pegged all the way to the right, so that wall is sopping wet. Oh, I don't see any mold. This wall, that needle is all the way over there sopping wet. Don't see the mold, but that doesn't mean that there isn't any. We call the back side of this drywall, that paper-faced drywall on the back side, we call that Purina mold chow. This mold just loves to eat it. When you see that, there's trouble potentially lurking on that unpainted back side. It could look like this back in there, and the only way to tell is to take a look, cut an inspection hole and check it out. Is it there or is it not? And you can easily hide that with a blank cover plate for future inspections. Another useful use for this moisture meter is checking under chair mats with a slab on grade, concrete slab on grade. That's going to be potentially wicking moisture from the ground up through the carpet. And if you put this plastic chair protector over the top, it can trap the moisture underneath like it did here. And, because it can't ventilate out through the plastic. And that trapped moisture in the carpet can produce mold and mildew. Here's a dramatic example. See the big ring of the condensation underneath that thing where it dries along the edges, but it's trapped underneath here, and you're going to get the mildew smell coming up from there. So just another thing to watch for. Here's another test is a very common concrete moisture test kit that tells you how much moisture is coming out of the concrete, this calcium chloride test that just about any carpet or floor covering purveyor these days can set you up to do these tests to ensure that the concrete isn't putting out so much moisture that it's really not safe to put carpet or tile down on it without having issues. Another type of moisture meter has pins that you can poke into a wall And this is useful because the pads that we were showing on the last slides, they can sometimes be faked out by electrical or metal behind the drywall, and these pins won't be. So sometimes if you get a reading that looks wet with the pads, you can poke it with these pins to just confirm that there is moisture in the drywall. If you get above 18% in drywall, there's going to be mold growth ultimately. So that's a warning sign. It's got to be drier. You want to get it down under 14 at least if you can. 28, I've been told, is sopping wet. Here's 31. And so you know that there's going to be an issue there. And this can't just be allowed to dry. It needs to be aggressively dried because mold can get going in 48 hours. You want to get things dried out as fast as possible to avoid mold growth. When I do take measurements in walls, I often like to leave these little notes behind where I made my little holes just so people coming behind me can see what I found and maybe get a good grasp of the scope of the project as they head in there to try and dry things out. Rich, you want to talk about thermal imagers?
This technology has gotten more affordable, very good technology. If you have a lot of buildings, it might be a good idea to think about purchasing one of these devices. It's good for moisture, it's good for energy, it's good for air leaks, and also looking at mechanical equipment, air conditioning coils, heating coils, fuse boxes, breaker boxes, things like that. So the technology is down around $3,000 to get started, and but if you've got a lot of buildings, it could be a real good investment. It allows you to take a photograph, and you can see in this photograph the dark spots, the blue spots, that's moisture. So you can have a photograph like at this classroom. You see that it's 44 degrees there. That's a water leak in that wall cavity. Then when it's repaired, you can go back, compare today with last month, and find out if you've actually fixed that problem.
It might lead you to something like this that's hidden up there, which you don't want. There's some black mold. We'll talk about black mold in a moment. Temperature, relative humidity, and dew point are important parameters to get a grip on in a place. Relative humidity, especially important because we live very moist lifestyles. And if we accumulate too much moisture in a house, we're going to get to the point where we're going to get relatively warm surfaces becoming condensing surfaces, where moisture is going to condense out onto that surface and cause a potential issue. Another way to measure relative humidity is using a sling psychrometer. These are cheaper. They're about 50 bucks. And you grab one part of that and you kind of whip it around in a circle. If you've ever seen people use these things, spinning them to get the airflow past the thermometers there. I used one until I accidentally flipped one across a classroom. That kind of went to different methodology after that, but that's another story I'll save. So this is what happens when you're building up too much relative humidity in a place. That could be double pane glass, which should really never get condensation on it if there's a nice moisture balance inside the room. But get too much condensation, and if the anything that's below dew point, or the temperature at which condensation is going to condense, moisture in the air is going to condense out onto a surface like a glass of ice water, you're going to get that condensation. And here's just more proof that just our breathing produces all this moisture that maybe you don't think about it, but just a family of 4 or 5 breathing in a house produces a tremendous amount of moisture that needs to be ventilated out to prevent condensation issues. This was an apartment with just 2 students living in it. Baseboard electric heat. They kept the place locked up really tight and couldn't understand why they kept ponding water on their windows. And it's just dripping down the windowsills because relative humidity in there was about 70%, way too high. So you get condensation on the glass, it ponds down here, drips down into the wall cavity, causes all the mold growth, all completely preventable with good ventilation. What kind of mold is this? Is it black mold? You don't really care. Rule of thumb is mold inside bad, mold outside good. And unless a doctor, go ahead.
Well, I was going to say what we're looking at there is not a leak in the building, but just a cold corner and people breathing in that bedroom.
Right. And that's where mold's going to start first. It's going to start at the wettest spot, and the wettest spot is typically the coldest spot. And down in these corners here, typically there's lots of wood and less insulation. So it's slightly colder. That's the last area to dry out, the first area to get moldy. You want to get materials thoroughly dried within 48 hours to avoid things taking off like this. Now that's been there a whole lot longer than 48 hours, but you don't want to go there. Tell us about smoke tubes, Rich.
Like Dave said, we want to control the pollutants in our building to keep them away from people, keep people away from the pollutants that cause a reaction. And so what we do is we track the airflow so that we see that air is not coming out of a crawl space into the bedroom or into the living room. We want to make sure the air is going from clean to dirty. So in a house, you don't want the air coming in from the garage or a crawl space or some other location that could bring in odors, moisture, and contaminants. You want to make sure air is going up the flue of the wood stove and not backdrafting, or backdrafting down a propane or natural gas water heater. So we track the airflow, make sure it's people have the clean air, the dirty air is going away from the people to reduce exposure.
So in this example in a school, you want to make sure that the air is moving using a smoke tube from the classroom to the shops and then outside, from the library to the chemistry class and then outside, right? Clean to dirty and then outside. Here's an example. The only positively pressurized room in this building was the shop, the wood shop. And here, you know, more than 100 feet down the hall is wood dust that has come out from where it should have been collected and settled out onto the lockers. That's an airflow direction issue. This is how we look when we're first looking at an indoor air quality issue, how we try to set it out in our minds to solve it. You got the person impacted, and there's three legs to this triangle that's adding up to the impact. One is the pollutant that's being pushed or pulled along a pathway by a pressure to impact the person. Now, if you cut any leg of this triangle, you're going to solve your problem. You either find and eliminate the pollutant, you block the pathway, you reverse the pressure so the pollutant sucked back towards its source away from the person, and you'll solve your problem. You want to do the cheap stuff first, but this is how we try to lay it out. So, for example, you have a contaminated crawl space under a school. To remove that source is going to be extraordinarily expensive. So one thing you can do is close the pathway, seal it, and if you can, block that so that it can't get at the people, and you've solved the problem. If it's still leaking up and you're having trouble controlling that with the force of warm air rising, sucking on it, then you can put pressure control in, reverse the pressure from the classroom to the crawl space and then outside by adding a fan in the crawl space that's creating negative pressure that's sucking on that crawl space. So air's classroom, crawl space to outside, and you solve the problem. Chemical smoke then can be used we just barely crack a door, and we want to know is the air going in or out. If the room's positively pressurized, the air will go out. If it's under negative pressure, it'll come in. If it's neutral, there won't be any airflow at all. So you don't want to see this from the chemical storeroom where air is coming out into the classroom, right? Now this titanium tetrachloride, it's about $50 for a bottle, right, Rich? A lot of that expense is for the very specialized bottle that won't get eaten up by the titanium tetrachloride, which is a liquid that you get in a glass vial and carefully pour in on top of some fiberglass wadding in there. And when that liquid contacts air, it turns to this dry powder smoke that is very effective at telling where little slipstreams of air are going, which direction they're going in. But this stuff is very corrosive. It'll eat equipment, electronics, so you got to be careful where you put it. And this is the stuff that's used to test HEPA face masks. So if you breathe it, it's irritating. So you want to keep it away from people's faces. Use tiny little amounts of smoke. And you know, we dramatize this to catch the photo. But just a very small amount of smoke will typically work. But smoke tubes are very effective for determining the critical importance of airflow direction in a school, like clean to dirty, and then outside, or a home for that matter. You can check to make sure that air is going up the flue the way it's supposed to with a smoke tube. Tell us about the pressure gauges, Rich, when you want to put a number on the pressure.
Well, we're starting to use pressure gauges in a lot of places across the country because they're essential for blower doors and duct blasters to test your ducts. So we're using pressure gauges a lot in our buildings. And looking at the previous slide, we check the pressure in a combustion zone to make sure we're not backdrafting that equipment or a wood stove, other combustion devices. So the smoke is nice, but we like to have a number to ensure that we're not causing a problem. And these pressure gauges measure very sensitive pressure differentials. And that way you can document that you've got a robust pressure to ensure that the air doesn't get loose from a contaminated zone. We measure in the room compared to outside of the room. So we can compare a house to a crawl space, a school to a restroom, a classroom to a lab storage, a maintenance shop to the outside, just to make sure we're not causing a problem with these pressure differentials. You can see that we're talking to this teacher about the pressure in their zone, describing why they're having a problem. And I think the next slide shows what the problem is. You can see in this slide that if you could back up one, Dave.
Sure.
If we take a quick look at this slide, you'll see that the ceiling is positive pressure compared to the room, which is under a negative pressure. So air was coming out of the ceiling into the classroom. What we'd like to see is a basic map of your facility showing what zones should be positive with air coming out, which zone should be negative with air going in. So you'll see that the office air needs to go toward the science lab. The language class wants to go toward the science labs. The restroom wants to suck on the building so that we don't get that air loose in the building. So we like to have sort of a map of the way the air should be moving in our buildings or in our houses.
These are very small pressures that we're talking about. It doesn't have to be a wind tunnel. Only about 25 pascals of negative pressure are necessary to keep a room from allowing its contents to spill out to the rest of the structure. And just to demonstrate with Rich's wife Sherry here, what a small number that is. That's a tenth of an inch of water column. And an inch of water column is the amount of pressure it takes to suck water 1 inch up a straw. So a tenth of that is about 25 pascals. It's a very small pressure, but that's enough to provide robust containment, as Rich likes to say, of whatever bad stuff is going on in that room to not get to other places. So you can do a quick check with a smoke tube to make sure that air is going the direction you want it to, and then you can document how much pressure is making the bad air stay inside with a pressure gauge if you need to put a number on it.
And this prevents people from coming back at you later on and saying they were exposed, because you've documented that you're maintaining a safe and healthy facility.
So here Rich is checking the pressure differential between the classroom and the crawl space above, and interestingly, air is coming down with the door closed or open now. I can't remember which. Anyway, the room was depressurized, so it was actually sucking on the space up there, and look what's up there. So now you got fiberglass coming down, both from gravity and from air pressure, and we don't want that. So this is a flow hood, a balance hood. What do these cost, Rich? Aren't they a couple thousand?
Unfortunately, these are about $2,000 these days.
Yeah, but this is a great way to, if you ever have your building balanced, the engineers are coming to check things out. It's great to have one of these just sitting over in the corner not doing anything, but to let them know that you know also how to check airflow and can double check their work. But this just is going to tell you how many cubic feet per minute are going in or out of that duct or return up there. And that'll put a number on it. It's another handy gizmo that works with the pressure gauge to measure bathroom fan exhaust, just to let you know that they exist. And these are not very expensive. And this guy here is, what, about $600 now? Maybe less.
Yeah, you can get them less than that. That'll do a good job. The problem with a lot of our exhaust fans is they make noise, but they're not very powerful. Their performance decreases over time, and oftentimes they aren't even put in right. So they don't really move much air. They just make noise.
Right. Okay, on to carbon dioxide. Rich and I really like to use carbon dioxide diagnostics to determine the adequacy of fresh air ventilation in schools, and I like to do it in residences too. I often find when I walk into a residence and I measure CO2, that's very high, higher than a classroom with 30 kids, higher than the level we want to have in there. So it's a good indication that they need to flush out their place and freshen things. We measure CO2, carbon dioxide, because it's easy to measure it. And we know that as CO2 builds up from our breathing, just from our respiration in the space, everything else is building up too, and everything else is too difficult to measure. CO2 is easy and relatively cheap, so it's a surrogate for the buildup of things we don't want indoors. We like to keep it below about 1,000 parts per million in a classroom environment or any environment for that matter. Outdoor air is about 400 parts per million carbon dioxide worldwide. That's slowly creeping up with climate change, but don't get me started on climate change. So if you're keeping a room under about 1,000 parts per million, that when it's fully occupied, that means that everyone in that classroom is getting 15 cubic feet of fresh air per minute. 15 CFM per minute per person of fresh air. That's a lot of fresh air coming in. And that'll keep things, that's what you're looking for, to keep things fresh. So ideally, 400 is outside. You want to keep it in this range here. It's quite possible you could be over-ventilating and wasting money, more fresh air than's necessary, especially up in Alaska. And when you under-ventilate and things get stuffy and allergens and whatnot builds up, you sneeze, and that sneeze stays in the room for hours. Not good. Okay, there's the pro tip to summarize what I already told you. CO2 builds up, so does everything else. You want to check your instruments outside for reference to make sure, just a quick check to make sure they're in calibration. Should be about 380 or 400 when you're outside. Shows you're at least close. So when you walk into a room, a classroom, doing a walkthrough survey, first thing you do is find out what's going on, what's the number in the middle of the classroom with nobody breathing on the instrument. It doesn't even have to be the middle of the classroom, but just ambient air in the classroom. Write that number down. Then go to where the fresh, go ahead. What's that mean?
Or a living room, bedroom, kitchen in a house.
Right, anywhere. And then check where the fresh air is coming in, because that's your only source of fresh air in the wintertime with all the windows closed, and that's when we like to look at these buildings to see how well the mechanical systems are keeping up with demand for fresh air. But check that number. You want it to be under your target of 800 or 1,000, right? Somewhere in there, because if it's coming in at 1,200, it's obviously not going to get you down to where you want to be, under 800 or 1,000. So compare the number coming in to what's in the middle of the room. Make sure that it makes sense. You're looking for it to be under about 800. Why do we end up with rooms that have high CO2? Well, sometimes it's the teacher turning off the fan unit and not realizing that that's the only fresh source air because it's too dang noisy. And they get very creative. This teacher is showing us how she bypassed the lockbox with a pencil. Could hit that little button to turn the noise off.
The other side of the coin is we have houses with baseboard heat or a wood stove, and they don't run a ventilation system. So the air is very stagnant in some of these homes, and the people need to understand they do need some fresh air, and the CO2 is a good indicator.
Okay. This is humor brought to you by Rich. Another reason you can have high CO2 is the fresh air intake is completely plugged. This one was plugged with organic matter in the first place, and then the building was painted, and they spray painted over it to make sure that it never came clean. So you want to check your air intakes. Now you can also record over time carbon dioxide levels and all these parameters, CO, CO2, temperature, and relative humidity on one of these meters. to show how things vary over time. So if you're in a classroom setting, you could see how the kids come in, they go on break, they come back, the breathing goes up, another little break. You can see how things vary over time, which can be very useful instead of just getting a snapshot. So it can tell you if this is your target, maybe they're spending too much time over that target, and you can make adjustments to add more fresh air to such a classroom. Tell us about these little hobos, Rich.
Those data recording instruments that do the carbon monoxide, carbon dioxide, temperature, they run around $1,800. This meter measures carbon dioxide very well, and it's about a $600 meter, so much less money, but it does not data log. So you can get those in conjunction with the little Hobo brand data logger, which is cordless, and you combine those together, and now you have data recording for the CO2. So you can see when it builds up, when it decreases, and it gives you a real good clue about what's going on with your mechanical system or your occupancy, how they're operating that room or that building. And that combination is about $650, so that's a pretty good buy for the money.
And when you are measuring, like I said earlier, you always want to explain the numbers. People like the numbers, but make sure they know exactly what that means. Rich made up these charts to carry around to demonstrate to people just what the numbers mean. Carbon monoxide is another thing that's easy to test for and critically important to defend yourself from. This is a real-time carbon monoxide analyzer. You want to make sure that you don't have issues like spillage or backdrafting from your hot water heater or any other gas appliance in the house. But picture your house closed up tight, and you've got a bunch of exhaust fans running, and the dryer is running, say, another basically fan sucking out of the house, and there's only one hole to the sky, and that's the flue. It's just physics. As all that air going out, it's got to get some makeup air, and it's just going to pull it right back down the flue and into the building. So you can protect yourself with a carbon monoxide alarm. You can see here the sign of the spillage off to the side there on the drywall. These carbon monoxide alarms are readily available and quite inexpensive. They vary in quality, but they probably all work at least to some point. And it's good to put them up where you can hear it, at 18 inches from the ceiling or so. Rich carries this light meter around and finds a lot of issues with light, don't you, Rich?
Yeah, if things are too bright, people can get headaches, stress, fatigue, and if the lighting is not strong enough, the same thing applies. They can be affected, and they think it's a health issue, which I guess it is, but it impacts performance, achievement, well-being, and lighting's really important in our spaces. So it's good to check our offices, schools for proper lighting levels. You can also save money by turning down the lights that are too bright, and make sure you have good quality lighting. With the new energy efficient lights, they put out a good quality of light. Noise is also an issue. We measure noise because that can cause fatigue, dizziness, headaches, so on and so forth. So if a space is real noisy, we ought to do something to eliminate that noise or reduce it to a reasonable level. Some of our heating and ventilation cooling equipment can whistle and rattle and make noises that kind of drive people crazy by the end of the day.
Okay, particles are very important in indoor environments. Just the whole world smashed to smithereens and floating in the air, a variety of stuff there. We use these particle counters. They're pretty expensive. I think it's about $4,000 for that, but quite accurate. It's a laser particle counter, measures 6 different size parameters from 0.3 to 10 micrometers. 10 micrometers, the big chunks, about 1/10 the width of a human hair. You can use them to check vacuum. Sometimes vacuum is the issue, taking big chunks and making them small and spewing them out the back end, making a haze in the air. So we recommend using HEPA-rated vacuums, but that's one use of the particle counter, is just to demonstrate a lousy vacuum. When we check the particle count indoors, we're generally just checking it in relation to outside. As a rule of thumb, you want to have inside particle levels be half what's outside. Of course, that varies depending on the conditions outside. But just as a general rule of thumb, if you're less than half what's going on outside, you're doing pretty well. And that I learned from a guy that looks at hospitals. So if the school's less than half the particles inside than outside of the fines, the 0.3 micron ones especially, I think the filtration system seems to be doing okay. But you can compare room to room. You can see what's coming out of the HVAC system. See if the ducts are a source of particles as all this lining comes apart and is blown out of the system by the airflow. Ends up as particulate. Here they're checking an air cleaner out and absolute zero. So that air cleaner really works. That is particle-free air coming past that filter. And here's one that doesn't work so well. You can see 0.3 to 10 microns in all those ranges. Okay.
Before we move past particles, Dave, we want to make sure we think about wood stoves, pellet stoves, and in residential situations where there could be a lot of particles because of the combustion products or old carpeting, activities in the house. Sometimes there's tobacco smoking, so candles, things like that. It could cause a lot of particles, cooking. So using a particle counter in residential situations can really help those with asthma and allergies and respiratory issues.
It sure can. I'll tell you a little story. The other day I was in a house with a gentleman who, when he's at home, he can't walk down to the mailbox and back without having to stop and catch his breath. Yet he goes to the doctor and gets stress test and does fine. He can go to Costco and walk all the way around with no issues at all, but he goes home and it's just that much worse. It took a particle count in this house and there was about 350,000 versus 15,000 outside. Well, once we just blew his place out with fresh outside air for about 10 minutes, we got the numbers outside and inside the same, about 15,000. And he did that every day and problem solved. So we don't know what the particles were, but it just emphasizes. Make a wind tunnel out of your house once a day. It's a good idea to just remove whatever's building up in the air, because what you're breathing inside is outside plus. Outside plus. You want to get rid of that plus as much as possible, assuming that your outside air is good in the first place. So talking about testing.
The important thing to realize is these particles are invisible, and you really can't tell whether someone's being exposed to high levels without a measurement device. So if you have a lot of wood stoves and other issues in your area, it might be a good investment, because what gets measured gets fixed and controlled.
So talking about testing and interpreting testing, airborne tests, I guess we'd start by looking at this room and ask the question, would you test this room? I've seen it done, but what would be the point? You know that it's moldy. You don't need to pull an air sample in here unless you're an attorney or a doctor and have some special reason to know why. But testing can be overrated. The American Congress of Government Industrial Hygienists and other experts say that it is very unlikely that airborne mold samples will provide evidence that can't be more easily and reliably obtained by a thorough inspection. So testing for air testing for mold and other particles is a last resort. Because say you do find a lot of mold in the air, you still got to find out what the source is and look for it physically. So we suggest skipping the test and just doing the thorough inspection and see if that doesn't get the job done. And when I talk about testing, I'm talking about grabbing a sample that you need to send off to someone else for analysis. We're reluctant to do that. Almost never test for VOCs. I've never done a VOC test that panned out with any answers that were useful, and it's extraordinarily expensive. So So just keep in mind we're reluctant to test, but when we have to, with a gun at our head, this is what we typically do is we use a spore trap. These are $7 to $9 a piece, and you can see there's a wedge here. Air gets sucked in by the pump, and as it moves into that wedge, it gets sped up, and it impacts on a sticky plate back here. So any particles in the air get impacted on that. The analyst takes that plate out, looks at it under a microscope, and sees what particles are in the air. There's a pump that's sucking the air in through the cassette, trapping the particles on it, right? Runs for 10 minutes. So you get a 150-liter sample. But you got to ask yourself, do you need the results of this test to make a decision? If not, just proceed. Save the money. Spend the money fixing the problem that you already know you have. One reason you might want a sample is if you had a reason to identify an individual pollutant, or a lawyer or a doctor might need to know for some special reason. But if you're going to do it, the way to do it would be to grab a sample outside for reference, and then you're going to get a snapshot indoors from the breathing zone where people are breathing. Now we call it a snapshot because the numbers that we get back from this report are going to be either higher or lower than the truth of what's really in the air, because it's a snapshot and those numbers vary throughout the day. We really should be taking 20 or 30 samples to be really, really accurate, but we find you don't necessarily have to be. And these are 50 or 60 bucks a piece for analysis, so you just can't afford to do that. But we get an idea, maybe get a clue from taking a sample. So we get a result back with so many spores per cubic meter. Is that good or bad? We don't know. It depends on the people. It depends on a lot of things. It always depends. There are no magic numbers. Say 600 spores per cubic meter is bad and 200 is good. You just can't say that. This is how we interpret it. When we take samples, we take them inside versus outside. We do want less mold to show up on the sample that we took inside. And we want it to be a similar mix of molds inside and outside. That would be a good sample result. What we don't want is to find molds on our indoor sample that do not occur outside, because that may mean that the molds we're collecting indoors are sourced indoors and are growing indoors, not just wafting in from outside. Here's just another example of the utility of this. We were sampling out of the ceiling plenum, and lo and behold, we got a bunch of mineral wool fibers coming down out of that air stream. So you get these big reports. I'm just giving you an idea what they look like. Background particles always going to be higher indoors than outside. Same with dander. Our skin scales going to be much higher inside if there's any outside. But analysts can look at the relative mix of particles that are identified and see if that doesn't manifest itself as an issue. Does it point to an issue? So we look at the totals. We want to find, as we said, more mold outside than inside. That's good. What may be of concern is we're finding molds inside that are not outside, like chetomium, which I happen to know loves wet drywall. We've got some of that in this sample. And here's some more aspergillus and penicillium that are inside but not outside. So is it an issue? Maybe. Maybe not, but it grabs some clues that you can go farther with potentially. It's just an idea of what it looks like under a microscope. That's our skin. Paper fibers, manufactured fibers like nylons, mold spores. Here's your penicillium and aspergillus, stachybotrys, the black mold spores, crystalline particles, eraser rubbings, tire wear. If you live near a freeway, you're probably going to find a lot of this in an air sample. Where do tires go when they wear out? To tiny little rubber balls floating through the air. Starch, this is typically associated with cosmetics. A lot of starch in a room can point to a problem. Soot. But they can identify all these particles and then kind of characterize what's going on in the room. Another effective method of testing when you have to is testing settled dust. So you take a piece of green box magic tape, put it on that surface, and just press it hard onto the dust. Peel it back, put it in a clean Ziploc baggie, and send it off for analysis. Pretty expensive, about $400. typically a set of 3 samples: brand new dust, kind of medium dust, and then very old dust, like off the top of a door. Because if it's in the air, it's going to be in the dust. And analysts that are well-trained can, again, identify the different particles, the relative number of particles, and characterize what's going on in that indoor environment. And this is what they're looking at under the scope. You can identify all these different things, and does that mix point to an issue?
I think what's important, Dave, is we don't want to just measure for molds and ignore all the other pollutants that could actually be the source of the problem.
Right. Yeah, the good thing about mold is there's a little bit of hysteria about it and a lot of press, and so when people start feeling sick in an issue, they think mold. And when they call, they ask about mold, which is good because at least they call and ask, but it may be other things or a combination of things that are actually impacting their health. You can tell whether fiberglass in the samples from the ventilation system or whether it's from ceiling tiles. Anyway, they're very, very good at what they do. And finally, radon. It's easy to test for, and it's only about $50 or $60, I think, a sample. You can send away for accurate test kits. This is about 5 days, right, Rich? You just take the cap off and expose that to the environment, like a crawl space, one in the crawl space, one in the bedroom. Seal it up and send it off for analysis, and they'll tell you if you have any radon there. Or you can take longer-term radon tests for months to get a better, more accurate idea of what's going on. But radon is a big cause of lung cancer, so it's good to rule it out of any indoor scenario. And that about wraps us up. I wanted to let you know that we have this disc and others available from our website, nwcleanair.org. And I'll send you a hard copy, or you can download your own or just watch it online. And I appreciate your attention. Looking forward to questions.
I would add another couple of resources, Dave. You have asthma and mold and moisture DVDs,
right.
And our office has duct sealing DVD and a brand new air sealing DVD, which are both for residential. And we know pollutants can be transported by the ductwork and through air leaks in the homes. So both those videos apply to indoor environments as well. So we've got a wealth of DVDs we've developed.
Yeah, so
and
between Rich's website and mine, right, they're all free. So, Gillian, I guess I need to pass this back, huh?
I think I'm going to go ahead and do it. Got it back to my screen. So we're going to go ahead. Let's see if we can see my screen here. See here. Okay, can you see my screen?
Yes.
Good. All right, I'm using Dave and Rich. So first of all, I just wanted to say really quickly thank you. These guys, as you can tell, are just an enormous resource of information, and do go ahead and call them, not to send too much traffic your way, but they are a great resource, and they can also direct you to either organizations or people if they can answer your questions. So make sure you get their contact information. Before we move straight to questions, I'm going to do a couple of things really quickly. For those of you who might not have heard this before, you can enter questions now. There's a little control panel on your far right. Type in a question, click submit, and for example, there's a couple here now. I'm going to read to our speakers, and they'll answer them. We'll hit a few of those questions, and then, like I said, I'm going to unmute it for everyone so you can have a dialogue. While we're waiting, this slide, resources, you'll have access to this slide. And then Tribal Healthy Homes Northwest, our organization, will have, I'm going to click on it. Nope, that's not going to work. Anyway, when you click on it, you will have, there's a link that says webinars. You will be able to download this webinar that you heard today. You'll be able to get the slide with resources. There's a few other things, including I wanted to mention that Mansell Nelson and ITAP has an excellent indoor air program. And they do, as many of you know, they do training nationally, but one thing Mansell's trying to develop is a guide, sort of a matrix for tribes. So when you're looking at purchasing specific equipment, you have some guidelines about cost, reliability, manufacture, and he is working on that now, and once it's ready, it will be on their website as well as ours. So I'm just going to do a quick poll while you guys are submitting questions. I'm going to do a quick poll just to find out who's on the call and some of the information that you have. Let's see. Here's a poll. It should come up quickly. First one is just which department or organization you represent. Okay, a few more seconds and I'm going to close that poll. And I'm going to share the results. Should come up. Are you guys seeing the, Rich and Dave, do you see the poll results?
Yes.
Good, okay. So, yeah, we're slowly working. My objective is to have a good balance of housing, health and safety, and health clinics. So we're getting closer to that with these calls. My next question, though, is regardless of which department that you work in, are you currently using any instruments in your investigation? All right, close that one and share. So it looks like there's actually, even though the majority, 67%, are not actually using instruments right now, 33% is pretty high. So it'll be great to unmute in a minute and talk to you all and find out what you're using. So the last question, really quickly, is which of the following are you interested in? I don't know if you can click on more than one, but one is just purchasing equipment directly for your tribe. Another is participating in a tribal equipment loan program. And then contracting out, which is what many of us, I know I currently do when I need to do more detailed investigation. And while this poll is up, I should say that I'm currently courting a couple private companies to try and develop it to get a series of 2 or 3. Basically, you saw the slide that Rich and Dave brought up showing sort of the basic instruments that they use. We're trying to have a set of those within Washington, Oregon, Idaho, and Alaska, so you could theoretically check it out for a month. You'd have to take a course first, but check it out and use it back at your tribe for 2 to 4 weeks, do some testing, and then you'd have to put a damage deposit in, but then get that back and send it back. So we're working on getting, there wasn't quite enough funding to do that this year, so I'm looking to the private sector to see what I can come up with. But I'm going to go ahead and close that one now and share the results. So it looks like there's a pretty good balance there. And on the contracting out on IAQ investigations, I should also note that one of our objectives for next year for Tribal Healthy Homes Northwest is to move towards certification and more programs that give you sort of tribal staff who are accredited so that you can actually keep the labor and the resources and the training within the tribe and end up paying as opposed to having to go outside the tribe and contract out with a non-tribal firm. So anyway, that's that. I'm going to go ahead and open it up now. I'm going to unmute everyone. So hold on a second here. Give me a minute. You can tell I'm a little, okay. I think I'm going to have, I'm individually unmuting everyone who's on the call. So it's going to take me a minute. While I'm doing that, I'm going to read one of the first questions that was actually entered here, which was someone asked that they said, do you need a blower door set up in order to use the pressure gauges, the blow hoods that you showed in your slides, or those how to blow door set up? And Dave or Rich, do you want to do that? I think you're, make sure. Okay, Dave,
I was muted.
I had you muted. All right. Did you hear
Rich, are you muted? Because Rich should answer that question.
Okay. I'm checking.
Why don't we unmute Rich? I'm
working on it. I take a track.
Morning.
What? Have an audio. Have an audio.
Anyway, I can answer that question.
Dave, are you still there?
I sure am.
Okay. Did you want to go ahead? If anyone else is on the call, I'm slowly unmuting each of you. Feel free to introduce yourself, what tribe you work with, or organization, and ask a question to the speaker.
To try and answer that question, Rich is really the blower door expert, but you don't have to have a blower door to use that instrument. It's an integral part of using the blower door.
Okay.
But that's, I think, getting into how the blower door works is probably too much detail for this call.
Exactly.
But Rich is the guy to call about that.
Can you hear me now?
Detailed instructions. I can hear you now, Rich.
Okay. Can you hear me now, Dave?
Yes, sir.
Just a minute, I'm getting feedback. Let me see what I can do here.
I think we all might be getting feedback. I would just go ahead and talk, Rich.
How about now? Can you hear me?
Yes.
Can you hear me?
Yes.
I don't know that he can. Okay. If any of you can talk, go ahead and ask a question. If not, go ahead and submit one in the box. I see that, I think I've got Jonna. Are you still on the call? Nope. Let's see here. Who else do we have here? Jamie, are you on the call?
Yes.
Okay. Good. We have a live one.
I have a question.
Jamie, did that answer your question? I see another written question coming in. Did that answer your question about using for pressure testing?
Yeah, kind of.
Okay.
You'll get a good answer if you talk to Rich.
Okay.
He's put together beautiful documents that explain step by step how to do all those procedures.
Twali, are you still on the call from Spokane? Okay, I'm seeing names here, so I'm going to go ahead and just read. Oh, here she said yes, but we can't hear you. Can you submit, if you have any questions?
Can you guys hear me? Hello.
Hello, I'm still here. Fayette, were you there? Did I hear you?
I got a question here.
Oh, go ahead.
Okay, we have a public building. It's a multi-purpose building. It has there's a wasateri, a laundromat. There's also a clinic, and they're both on the first floor. And there's offices on the upstairs. That's a two-story building. There's also sour facilities in the upstairs, second floor. And I just started work in February building, and I noticed there's a lot of dust and poor air quality, and it's a public building. So is there funding out there that we could possibly apply for if we get this indoor air quality issue documented with those instruments? Because we got a lot of dust in here, and I had 3 mild asthma, I'd say it's mild. I never had asthma attacks before, but having constricted airways I never used to have constricted airways, and when I did it, it just made my body get really mad. It just made me get really mad, and that I needed air. So we do have an indoor air issue, which is community building, and also we have indoor air quality issues with a lot of the housing. I just thought I'd let you all know that we do have indoor air quality issues.
And what village are you from?
Quinahawk.
Oh, Quinahawk, that's right, okay. This isn't Frank, is it?
No, this is Walter Johnson.
Oh, Walter, okay. Okay, thanks for sharing that, Walter. It sounds like you have some really challenging issues, and I'm sorry to hear about your asthma. Dave and Rich, do you want to see what you can provide there?
Rich, you're better on potential funding. But Rich
to do upgrades to
I'm not aware of
ventilation system.
Yeah, I'm not aware of specific grants. I mean, Rich gets a grant to go around and do a lot of travel work on indoor air quality, but I don't know of a specific pot of gold that the tribe could apply to try and help remediate some of these issues that are going on. But I'll bet that Gillian will stay on top of that. If anything shows up, she would be the best contact to get that information when such funds come available out to the people. But I think a lot of us are on our own.
I would just add, Walter, and to anyone else, that it's purchasing instruments with EPA dollars is still, it's kind of unclear yet as to whether or not you could, under what grant and whether you could purchase them. But under any HUD funding you have for housing and housing rehabilitation, Department of Energy, anything related to weatherization, there's at least half of the instruments that they discussed are things that you can purchase under the HUD or the DOE type grants, because they're looking at airflow, temperature, humidity, and a variety of those instruments are good indicators for indoor air as well. So that's usually the kind of grant where you can put that into a line item and include it in your purchase. But absolutely, like they mentioned, if there's anything else that comes up, I would share that.
No, I know we have air issues with the housing. There are 55 homes scheduled for work to be done.
Okay.
That's the focus. And then I'm working in this building. I just started February. I noticed there's a lot of dust. I think it's coming from the laundromat. And I had 3 mild asthma attacks. I think they're pretty mild, because from what I heard about asthma attacks, it wasn't real extreme, but it constricted my airways.
Well, you know, the laundromat sends up a lot of red flags. I would have someone, if there's somebody in your community, well, go look at that, because it suggests maybe work. If it creates dust, the work may have some problems. I would certainly follow that up, especially so that you don't continue to have the respiratory problems. There's another question that just came in from Clyde. And just wanted to ask if there's any other additional webinars, and to say thanks that the speakers did an excellent job. So are you on your road show? When are you Are you're going to be at the asthma forum in D.C., but how about out here in eastern or western Washington?
You asking me?
Either one of you, yeah.
Okay. Well, actually, we're going to miss the asthma forum. I'd love to go there, but won't be doing that. But, you know, I am happy, and I'm sure Rich is too, to participate in, you know, more of these webinars. If you wanted one specifically on mold and moisture, for example, I mean, there's an awful lot of talking we can do on indoor air quality topics that may be of use to people to get into greater detail, especially on critical things like mold and moisture conservation. Or anything else anyone wants to talk about. This is not that difficult to get set up to participate in these. I'm happy to do whatever you want me to do.
Great. So there's one more question that, and I think I'm going to go ahead and mute everyone so we don't get this back. I'm going to try to do it anyway. Then make sure my speakers are unmuted. I'm just going to do that so we don't have the back. Here's the next question, which was with weatherization for the equipment purchases, are there reporting requirements for the results, or are there for educational outreach purposes? Briefly, I'll just say that I'm not aware of any reporting requirements because there aren't any indoor air standards for things like particulate CO2. And hopefully your grants shouldn't, they might want a quality assurance project plan, but even that is still evolving in terms of what that would look like because we don't have a standard set of measurement criteria. Donna at this staff, there's a list of equipment that we can refer to. And like I mentioned, Mansell Nelson is developing a list that will be on his website, and I will, as soon as that's done, it's probably still 2 or 3 weeks or a month away, but he wants to put something together so you can look to it for purchasing. And that's it. I'm going to change my screen for a minute and show you guys just a couple screens. Right now. This is OSHA. It actually has recommended indoor air investigation procedures. These are just a couple sites to use. These will be links. This is through Fluke, which we don't endorse, but what I like about their site is that when you go to Fluke, you can find case studies and online forums on a variety of questions with using and applying the different instruments. You can scroll down here so you can see. Then there's also user reviews. This is one, for example, I found a company that carries all of the different particle counters, but they also discuss you can compare the price and the features as well as user reviews. So I think this is all just good information in addition to talking to someone like Rich or Dave before you make any kind of a decision. I think that's about it. I'm going to go really quickly. This is Healthy Homes Northwest website. Click on webinars. This is later today or tomorrow. This webinar will be posted. And if you haven't joined, just click on join, and this form will come up. Join the work group. So with that, I'm going to go ahead and do you guys want to add anything before sign off?
Gillian, this is Fayette from Region 5.
Hi, Fayette.
How are you? I'm going to have to call you because we just had a training in Red Lake with the University of Montana, and I'll need to talk to you about it because I want to do a webinar to get feedback from the tribes, but I'll just call you at the 425 number there.
Excellent, okay.
Is that okay?
Sorry, go ahead.
So I'll call you.
Okay, that would be great.
Thank you.
Okay, and then everyone else, there was just one more question about sending any training times or dates or webinars. So one thing, if you go ahead and when you click join, then I have your email address. And so when we do webinars or when any of our partners do training, like the one Fayette just mentioned, but if ITEP or Montana State, there's a variety of organizations, but we will, I know you get barraged in your inbox, so I try to limit what I send out, but we'll send information specifically about indoor air training for tribes, not just but for tribes. So thanks again to everybody. I hope this was helpful. Give me a little time and you'll have all the slides up, or I mean the full webinar you can download. And if you have any colleagues who you think would benefit from this, when they download it and play it, they'll hear all the audio, or the lack thereof, from my earlier gaps. But anyway, and they'll be able to see all the stuff. So it's pretty useful. Anything else, Rich and Dave?
No, thanks for attending. Hope to do it again sometime.
Well, you guys were terrific. Thanks, everybody, and have a good rest of your week.
We will. Take care, Jillian. Bye,
Bye-bye.
everybody.